Okay, so dear students, I welcome you all for today's class. Our course title, as you know already, data mining, and I am Dr. Mohammad Siddiqur Rahman. I am the course instructor. So today what we are gonna learn, and the topic is machine learning, of course. So as I already told you in our previous class, what is machine learning? So machine learning is about a technique that is used to implement artificial intelligence that can learn from data by themselves without being explicitly programmed. That means you don't need to program a lot. Better, you can just give the data to the machine learning algorithm or machine learning models or machine learning methods, but you have to level your data. That means the machine learning is gonna learn data from the input data, then the work will be done automatically. So this is all about the machine learning. So consider one example. If you can take a look, these two picture, right? So first one is dog and the second one is cat. So suppose you are given a lot of data, like big data, hundreds of thousands of images of dog and cats, right? So how the machine learning can accurately classify which one is dog and which one is dog and which one is cat? How? So the data, what will be the data then? The data will be several images of dogs and cats. And what the machine learning will do, machine learning will learn from this lot of data. And finally, what the machine learning will do, finally, the machine learning will try to find a pattern of images based on the characteristics you already give to machine learning model. And finally, the machine learning model or classification technique or algorithm or method, which will classify the images, these two images accurately. That means which one is dog and which one is cat. So this is in fact the mechanism of machine learning algorithm. So in our today's class lecture, we will try to learn different types of machine learning algorithms we can use for the classification or regression or any kind of problems. Okay. So what is machine learning methods, or what are the different kinds of machine learning methods? Before going to that classification, we can maybe take a visit or take a look. What are the different definition or function of machine learning methods again? So machine learning is a structured approach for deriving meaningful predictions or insights from both structured and unstructured data. So you don't need to be worried about the type of your data. If the data is structured or unstructured, you don't need to be worried. So machine learning will find a way how to combine or how to extract or how to like function the data in a very good way. For what purpose? For the prediction or having some insights from both structured and unstructured data. So what machine learning methods mainly employ? It employs complex algorithms. So it uses complex algorithm that enable analytics based on data, history, and patterns. So one of the most important aspect of machine learning is to perform predictive modeling. So what is predictive modeling? Predictive modeling is a branch of machine learning that particularly deals with tabular data to explicitly find patterns or insights from the data available, right? So suppose you are given some data, regarding some specific variables. So what, and your objective is to predict or is to classify the problem. So machine learning models can be used there to predict your problem accurately. Okay, based on what? Based on definite patterns and or insights from the data available. So the field of data science continues to scale new heights enabled by the exponential growth in computing power over the last decade. So as you all know, today is the era of data science. Like you have a big computing facilities. So with the big computing facilities, so no problem with the data. So if the data is big or large enough, what you can do, you can apply several machine learning algorithms or like artificial intelligence modeling. So for what? To have some new idea from the available data. And data scientists are continuously exploring new models and methods each day, and sometimes it's scary even keep pace with the trends. So as you know, problems are everywhere and we are facing new problems every day. Every day there is a generation of new problem, like the new problems are generating every day, every hour, every second, right? So you need a solution. So as a programmer or as a data scientist, what you can do, you can give the solution. How you can give the solution? You can give the solution using exploring new models and methods. So new problems are coming, so you have to apply new models. So this is the beauty of the data scientist. Like data scientist can do everything because he or she is very good in like programming. So the data is not a matter then. So he or she is gonna apply some models or methods, and these models and methods can be used to extract the hidden information or extract the novel pattern or extract or to solve the specific problem, or you can explore the specific problem using new models or methods. So data are being generated nowadays numerously, and the problem is very new and a lot of problems. But as a data scientist, if you know or if you have a good knowledge in machine learning, artificial intelligence, or good programming command over the good programming languages, so you can solve those problems easily. So as I told you, machine learning can be used for both kinds of data, if it is structured, if it is non-structured. So the type of the data is not a problem in machine learning, but what is the problem with the traditional statistical modeling or the parametric modeling? Parametric modeling means the modeling that depends on the hypothesis or the assumption. So normal statistical or mathematical models heavily rely on the assumption. Without the assumption, they cannot run properly. But this is the advantage of machine learning over the traditional statistical or mathematical model. Whatever the data is about, there is no problem with the assumption of the data. Whether the data is structured or unstructured, machine learning can just, you can apply the machine learning for both data, and machine learning will automatically fit the data. For what? For a specific decision, and the decision could be prediction, it could be forecasting problem, it can be finding the definite pattern, it can be used to make some inferences. Okay, so what are the different kinds of machine learning methods available nowadays? So machine learning is mainly classified into three categories, as you see here. Number one is the supervised learning. Number two is the unsupervised learning. Number three is the reinforcement learning. So there are some categories of the supervised and unsupervised learning as well. In the category of supervised learning, you can find there are mainly two kinds of supervised learning algorithm or models. Classification. So if your problem is classification and regression, you can use the supervised learning machine learning algorithm. But if your problem is clustering, then you can use unsupervised learning algorithm or unsupervised learning methods or machine learning methods. Okay, so what is the summary from this slide? So machine learning can be of three types mainly. Number one is the supervised learning. Number two is the unsupervised learning. Number three is the reinforcement learning. But supervised learning and unsupervised learning can be of two types. Supervised learning can be categorized into two categories. Number one, like the classification problem. Number two is the regression problem. And for unsupervised learning can be used to see the clustering problem in your data set. So what is classification, what is regression, and what is clustering, we can understand in the next slides. So what is supervised learning first? So as the name suggests, the machine learning algorithms which learn from level data. From leveled data, that is called the supervised learning. That means you are given the supervision in terms of level. That means if you can take a look of the picture number one, and this is the another picture. So what is the level of this picture? The level of the picture is apples, and the second level of the picture is mango. So when the level of the data is known, that means the machine learning algorithm learns from level data. When the machine learning algorithm can learn from the level data, you can call those machine learning algorithm as the supervised learning algorithm or supervised learning model. So here the examples, you already define the level of the first picture, and the level is apple, and the second picture, the level is mangoes. So what you can do, suppose now you are given an unknown image and you don't know really the pattern, really the name, really the level of these images. So what machine learning can do here? The machine learning model can be used here to classify or to level these images. So definitely the image is gonna be the apple, because you already trained the machine learning model is that this is the characteristics of the first image and this is the characteristics of second image, and machine learning already learned the data. Machine learning already learned the data. So and the techniques of machine learning or the machine learning algorithm already knows the levels of your data. So already the characteristics are known to machine learning model. So now you are given a particular image. Suppose the image has no level, but machine learning model can correctly classify this image, because this is the beauty of machine learning mechanism. And this kind of classification is called supervised learning. That means in supervised learning, the machine learning algorithms learns from level data. That means the data must be leveled. Okay, and there is a supervision in terms of level. Okay, so this is called the supervised learning algorithm. So what is unsupervised learning algorithm? So as you can see in the picture, there is no level. The images are here. So what machine learning can do? Machine learning can classify these images either in group 1 and group 2. So what are the data in group 1? So in group 1, they will classify some images, particular images like the apples are categorized or classified into group 1s, and in group 2, the mangoes are there. So what is unsupervised learning? So the main difference between unsupervised learning and supervised learning is that in supervised learning, the machine learning algorithms can learn from level data. But in unsupervised learning, machine learning algorithms learns from unleveled data. That means when the data is not leveled, then the machine learning algorithm you can apply is like unsupervised. So unsupervised means unleveled data, okay, which is gonna be learned by the machine learning algorithm. So no given supervision in terms of level are given in supervised learning algorithm. So what is reinforcement learning? So this is a bit difficult algorithm, and like there is a huge differences between supervised learning, unsupervised learning, and reinforcement learning. Consider this example. So this is the aspect of supervised learning, in fact. So the agent and the environment, okay? So the agent will take some action, okay? And based on the action, the agent will get some reward. So these are the 4 aspects of reinforcement learning. So what are the aspects? Number 1 is agent, number 2 is environment, number 3 is action, and finally you are gonna get some rewards for each action. So these are the aspects of reinforcement learning. Consider this example. Suppose the computer and the like the chess board, right? So suppose you are gonna play with the computer. So the computer can also act like a human. So you can be the chess player and the computer can do the same, right? So computer can be used as an agent, whether the machine learning models can learn from the environment. So how the computer is like work then? The computer learns from the environment. That means the work. So each action, so each state means the movement. The movement is called the each state. So after having a positive state, you can say this is a reward. Good. So this is the one kind of example of reinforcement learning. So in the gaming applications, like the game are developed. So a lot of games are developed using the reinforcement learning. How the games are developed based on 4 aspects. Number 1, agent, number 2, environment, number 3, action, and number 4, state and reward. Anyway, in the academic research or in your research, most of the problems are supervised and unsupervised learning. So in your research, you can apply. So these are the like popular methods or machine learning methods, supervised and unsupervised learning. So in supervised learning, as I told you, supervised learning can be of many types. So number 1 is classification. Okay, so what is classification? Classification is about predicting a class or discrete values. So I can repeat, classification is about predicting a class or discrete values. So here data are leveled, meaning that they are assigned to classes. Consider some example, like you are gonna classify the population in your class. So what will be the classification? Either you can classify your friends like female or male. Maybe you can solve any problem, true and false, spam or no, non-spam, or fraud and non-fraud. So in reality, this kind of problems are called the classification problem. And by nature, because the data is of 2 types, right? Two categories, so two classifications are here. So by nature, this kind of problems, you can apply the machine learning problems can be categorized as the classification problem. So classification is one kind of supervised learning. Why? Because in supervised learning, the data is already leveled. What is the level data here? You can see the male and female. That means you already level your data, male versus female, true versus false, spam versus non-spam, and fraud versus non-fraud. So this kind of level data, the machine learning model, what can they do? They can just learn from your data. Already your data is leveled. So that's why by nature, this kind of algorithms are called supervised learning algorithm. So the decision being model is to assign levels to new unleveled pitches of data. Classification should be binary classification and multi-class classification. This is very important. Like suppose you have you are doing a research, so and you want to classify your problem, you want to classify the feature, or you want to classify the variables. So what kind of classification you can do? Either you can do binary classification, or you can do multi-class classification, no problem. Okay, so by nature, classification is about, or is a kind of supervised learning algorithm. Why supervised learning algorithm? Because in classification problems, the machine learning algorithms or method are used based on the level data. Okay, because the data are already leveled by you. So if we want to use the level data and the machine learning can learn from the level data, then the machine learning algorithm will be called supervised learning algorithm. So regression is another kind of supervised learning algorithm. So what is the difference between classification and regression? So if we go back, classification is about predicting a class or discrete values, right? Class or discrete values. But regression is about predicting a quantity or continuous values. So that is the main difference between classification and regression. So classification is all about predicting the discrete values, okay, or the quality of something, or the classes, right? So suppose your research is to classify the smoker and non-smoker in your class. So what factors might affect the smoking behavior of your friends or the students of Begum Rohilla University, Rangpur, Bangladesh? So this is a classification problem, definitely. Why this is a classification problem? Because the level data is of only 2 categories, and those categories are discrete, not continuous. But if your objective is to like take a look over the salary of a certain company, what is the employee's salary and what factors might affect the salary salary of employees in a certain company, then this is a regression problem. Why this is a regression problem? Because here you are you want to predict a quantity or continuous value. So by nature, regression is also a supervised learning methods. Okay, so here data leveled with a real value, think of a real number rather than the level or class. So this is the differences between classification and regression. I repeat again, in classification, you cannot think of a real number. You have to think about a level or class. So the classes are predefined in classification problem. But when the data leveled with real values or some quantity or continuous values or number, these problems are the problems of regression. Okay, anyway, both classification and regression are supervised learning methods or supervised learning algorithms. So examples that are easy to understand are time series data, like the price of a stock over time, the monthly sales volume of a store, salary, age. So these are the by nature the quantity or continuous values. So if your objective, if your research is to find these values, then you can use the regression technique. You don't need to use the classification, because here there is no leveled class of the data. Either these data are the volume of a certain quantity. Okay, so by nature this is a classification regression problem. So in supervised learning, classification and regression are both categorized in the supervised learning methods or algorithm. The decision being model is what the value predict for the new unpredicted data. Anyway, so these examples might give you a good explanation or understanding about the difference between classification and regression problem. So consider the first images are here. So because the data is level, both data are level, that's why classification and regression is supervised learning method or techniques. Okay, so in the classification problem, you can find the picture is dog or cat. Okay, so the machine learning, if you apply the machine learning algorithm to classify the images, definitely the output will be either dog or cat based on the pattern or based on the characteristics, right? So by nature, these are the what? These are the qualitative response variable, not quantity. So these are the categorized level data. Okay, and so that's why this is the classification problem. But then the values are discrete, these are not continuous, right? So in the regression problem, consider one example like the temperature and rainfall. So if you want to see the effect of temperature on the rainfall, that means how much rainfall you can expect in a day due to the temperature rise or fall, right? So this is also a regression problem. Why this is a regression problem? Because the variables denotes here is the type of like quantity or continuous values, right? And you are gonna predict the rainfall based on the temperature, right? So by nature, this is a regression problem, right? So the final output will how much rainfall you can expect in a day in centimeter, right? So this is a regression problem. So this is the basic differences between classification and regression problem. Okay, so in classification problem, the level data are not continuous. The level data are discrete in nature, right? So this is the classification problem. In regression, if you want to predict continuous data, then you can use regression modeling or regression machine learning techniques. Okay, so these are called the supervised learning algorithm. Why supervised learning? Because the data are level, right? You already know the level of the data, and machine learning will learn the level data. Okay, and based on the leveling, machine learning will classify or regress, okay, your data. So this is all about the supervised learning algorithm. So what is unsupervised learning? It's like the clustering is one kind of example of unsupervised task that involves grouping similar data points, right? Here, the data are not leveled properly. That means the unleveled data, there is no leveling of the data given. Then the machine learning will learn the unleveled data. Okay, then finally the machine learning will give the clustering output based on your data. That means clustering means grouping similar data points, right? So data are not leveled here, but can be divided into groups based on similarity or other measures of natural structure in the data. So what is clustering? The clustering is a method by which you can group the data based on similarity or other measures. Okay, so clustering is one kind of unsupervised learning algorithm. And another kind of unsupervised learning algorithm is association. So clustering and association problem are categorized in the unsupervised learning problems, right? So what is association? Association is an unsupervised task that is used to find the important relationship between data points. Okay, so consider one example. I already gave this example in our previous lecture. Suppose you want to buy bread. So which other product is related with the bread? Which other product? It might be jelly, right? So there are in reality, some products are really associated with the other products, right? But if you want to predict, if you want to classify those products, okay, and this problem will be considered as the association problem, and association problem is nothing but an unsupervised problem, and that is used to find the important relationship between data points. So clustering and association are categorized in unsupervised learning methods. Okay, so what are the different popular machine learning methods? As I told you, machine learning are mainly three types. What are those? First one is the supervised learning, and second one unsupervised learning, and finally reinforcement learning. So what is unsupervised learning and what is supervised learning? I already told you, and I already told you the differences, right? So there are many algorithms you can use for the supervised learning problems. Also, there are many algorithms you can use for the unsupervised learning problems. As I told you, these two methods are very popular for the academic research, right? So you can give importance based on these two methods, right? Or you can apply these two methods for your real research problem. So what are the different models, or what are the different algorithms you can use for supervised learning problems? Like linear regression model. You can use a simple linear regression model. Okay, for what? For the supervised learning problems. You can also use the logistic regression model. You can use, so these two models are categorized in the regression problems. If you want, if your problem is regress something, so you can use these two traditional regression model for your supervised learning methods or problems. And if your problem is like the decision tree structure, you can apply some of the decision tree algorithm like the decision tree and random forest. If your problem is the classification problem, you can use several models or classification algorithm like K nearest neighbor, that means KNN, logistic regression, naive Bayes, and support vector machine, SVM. So these are the models you can use for the classification problem. Okay, and finally neural networks. So you can also use the neural network. So here you can see numeric data and categorical data. Linear regression and logistic regression can be used for both for numeric data and categorical data, and decision tree random forest can also be used both for numeric and categorical data, but K nearest neighbor is used only for numeric data. You cannot use K nearest neighbor for categorical data. Logistic regression can be used both for categorical and numeric data. Naive Bayes can be used for categorical data, and support vector machine can be used for numerical data. Okay, so what kind of models are used for the unsupervised learning problems? So mainly unsupervised learning models can be used for the clustering and association rule. Okay, so what are the models or techniques you can use for the unsupervised learning problems? That means when the data are unleveled. For the unleveled data, you can use many techniques like principal component analysis. So this is one of the data reduction techniques. Suppose you have a lot of variables, right? You want to preliminary check some of the variables, or you want to reduce some of the variables. So you can reduce the dimensionality of your data. So one technique you can use to reduce the dimensionality of your data is called the principal component analysis. Okay, so the another algorithm or model you can use K means clustering. Okay, K means clustering and hierarchical clustering. So these three models or technique or method can be used for the clustering problem or dimensionality reduction in the supervised, unsupervised learning problems. What are those? Principal component analysis, clustering, mean clustering methods, K-mean clustering methods, and hierarchical clustering. And for the association problem, you can use a priori algorithm and FP3. So these are the models or techniques or algorithm you can use for the supervised and unsupervised learning problems. Okay, and these are the popular machine learning methods or algorithms. Okay, so each of these algorithms are encoded through the language such as R, Python. Okay, so R and Python are very popular if you want to apply these models to your specified data. So if your research is like that, like if your research related to these problems, how can you solve this problem? You have to use a language or you have to use a programming software, either R or Python. These two softwares are very popular for the machine learning problems. Okay, so there are some business application in this slide. You can take a look some of the business application of machine learning models. So as I told you, machine learning mainly of three types: supervised learning, unsupervised learning, and reinforcement learning, right? So what supervised learning is used for? It used for either regression or classification. Unsupervised learning used for clustering or dimensionality reduction, and reinforcement learning has the application in the game development or game developer, skill acquisition, robot navigation, real-time decision, right? So these slides show you the real-life business application of machine learning algorithms. So in a summary or in a nutshell, I can tell you machine learning can be of three types. Again, supervised, unsupervised, and reinforcement learning, right? Supervised learning are two types, mainly used for two kinds of problems, for the classification problems and the regression problems. And for unsupervised learning is used for the dimensionality reduction and for the clustering problem. And reinforcement learning has a lot of application as well. So these are the business application of machine learning methods or algorithm. Okay. So now, as I told you, as a researcher or as an academician, your objective is to predict something. Okay, to predict, suppose the COVID-19 incidence, you are gonna predict the COVID-19 incidence. What is the scenario of COVID-19 incidence in the near future, right? So if your objective or if your job is to predict something, or you can use the machine learning model for the predictive modeling purposes. So what are the different steps of predictive modeling in machine learning modeling process? So first, the problem should be formulated, right? You have to formulate your specific problem. Then you have to go for the data analysis. But for the data analysis, you have to process or pre-process your data, okay? And after the pre-processing, you have to apply specific algorithm, okay, for your specific problem. So, and you have to evaluate your result. That means the output you are gonna get, you have to evaluate that result. Okay, how you can evaluate? This evaluation can be done using several measures, using several machine learning measures. Even in the regression model, there are several measures how you can evaluate or fit your model. The idea is same here. Also, you can also evaluate your machine learning models. After the evaluation, or if the model is good fit, that will improve your result, right? And finally, you can finalize your model and make prediction. So this is a typical step, or these are the typical steps to set up a predictive machine learning model. Okay, so you have to follow strictly those steps if you want to have a good predictive result. If your intention is to have a good prediction result, these kinds of steps are very necessary and you have to follow one by one, right? So what are the elements in machine learning predictive modeling? So these are very important. Like suppose your objective is to predict the COVID-19 incidence, right? And you are applying some machine learning model. For what objective? You want to predict correctly, and your objective is to select the best model, which is the best classifier or which is the best machine learning model that can be used to accurately predict the COVID-19 incidence in Bangladesh? So for this mechanism, you need to learn some of the elements, basic elements. Those are used in predictive modeling using machine learning algorithms. What are those? So the suppose instance is one kind of element. Feature is also important. You have to know the definition of feature. What is the training data set and what is the test data set, right? So this is a typical data set. You can see this is the instance, okay, and this is the feature and the trained data set and test data set. So as you can see, how many data sets are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So training data set and test. Training and test data set are used to split your data. Split your data. That means you have to divide your data set either in training data set and test data set. Normally, the rule of thumb is that 70% of the data is considered as the training data set. So you can use 70% of your data. It can vary also based on your research problem. It can be 80% also. Even sometimes it can goes down to 60%. So 60-70% data is your training data set and the remaining 30% is the test data set. Because you are going to develop a model, you are going to predict the model to predict the COVID-19 incidence, right? So your data must be split in training data set and test data set. So let's try to learn this topic separately. So what is instance? Instance is an individual row of data in a tabular data set is called an instance. So this is the instance, right? So what is the feature? A single column of data in a tabular data set is called a feature. It is also known as the attribute of a data instance. There are input features and output features in a typical data set. Sometimes output features needs to derive from input features, okay? And data set, a collection of instances and features used in predictive modeling. So what is data set? A data set is nothing but the combination of instances and features used in predictive modeling. So a data set is usually divided into 3 independent data sets: training data set, test data set, and validation data set. So these are very important if you want to run your model as far as the machine learning mechanism is concerned. So if your objective is to apply the machine learning model, so you have to split your data set into 3 categories: training data set, testing data set, and validated data set. So these are for the validation purpose. Okay, you can apply your model separately in the training data set, you can apply your model separately in the testing data set, and sometimes you can apply your model to the validation data set as well. Okay, so these are the elements are very important if you want to have a good knowledge in machine learning research. So what is training data set? A collection of instances and features used to fit an algorithm, right? As I told you, 70% of your data is called the training data set. You can use 70% data as the training data set, and this is nothing but the collection of instances and features used to fit an algorithm. What is testing data set? A collection of instances and features used to test the fitting algorithm, right? So one is used to fit an algorithm, another one is used to test the fitting algorithm. So what is validation data set? A collection of instances and features used to evaluate the performance of the model or fitting algorithm, right? So used to fit, used to test, used to evaluate. So these 3 words mainly differentiate the 3 topics: training data set, test data set, and validation data set. So these are very important elements if you want to do any research using machine learning methods or algorithm. Okay, so consider these images or consider this example which I published in my paper. So I have an output and the output is here. So this is the target feature. This is the target feature. What is my target feature? Aedes aegypti abundance. Aedes aegypti is a mosquito. She is a dengue vector or dengue mosquito. I think you already know that. So what I did, I classified this outcome. I classified this response variable, or I classified these variables as high versus low. So what I did, I collected, or we collected the mosquito, different kinds of mosquito, okay? And we identified the Aedes aegypti mosquitoes from different kinds of mosquito collected from Thailand and from northeastern Thailand. So after segregating or after collecting or identifying the specific Aedes aegypti mosquitoes using the morphological characteristics, okay, I tried to classify the mosquito abundance. Abundance means the presence or existence in that locality or in northeastern Thailand. I classified this Aedes aegypti abundance as high versus low. So what is high and low? I used another measure here, the median. If the 50% above and 50% below abundance of Aedes aegypti, I classified high versus low. So I constructed these variables as my target feature. Okay, and to classify or to predict this target feature, I also use some of the input features. So these are the input feature. I use some of the socioeconomic variables, okay, like the socioeconomic variables of each household, like why the households have a lot of mosquitoes. So I considered some of the socioeconomic characteristics. I also considered the climate change and dengue knowledge, attitude, and practice. We also surveyed previously for the same household regarding the climate change and dengue knowledge, attitude, and practices from each household. Also, I also downloaded some of the landscape variables from the satellite images. Okay, these are called the landscape variables, like the household density, like the rice crop, what kind of production, what kind of trees, a lot of things. And finally, I also combined all the input together. So if I ask you how many variables are here, so there are mainly 4 variables. One is socioeconomic, one is climate change and dengue knowledge perspective. Number 3 is landscape variables, and finally I combined all. So these are the 4 kinds of input features to see the output. So then I use several machine learning algorithms to select the best classifier. So by nature, this is a classification problem. Why this is a classification problem? And this is a supervised learning problem. Why? Because the data is already leveled. And what is the leveling of the data? The Aedes mosquito abundance was classified into 2 levels, high versus low. So this is a classification problem. Also, this is a supervised learning problem. Then I use several model classifier or machine learning algorithm. Random forest, artificial neural network, K nearest neighbor, support vector machine, and logistic regression model. So I use the traditional logistic regression model as well. Then I tried to see the prediction, which model was the highest predictor accuracy. That means which model showed the highest accuracy of prediction. For what purpose? For the classifying the high versus low abundance of Aedes mosquito. Okay. Then how I can evaluate the performance of each classifier. I evaluated the performance of each classifier using 2 traditional measurement. One is rock analysis. This is called the receiving operating system. And another one is the confusion matrix. So these are nothing but the model selection criteria. How did I validate my model? Okay, so this is the typical workflow of the machine learning model I used for my research, which I published a day before yesterday. So you can take a look of the paper, this paper. So you'll have some idea how did I apply the machine learning model to accurately classify the mosquito abundance. So this paper is really helpful for the policymaker if they really want to know the accurate classification or accurate existence of the mosquito. So they can apply the random forest. And I found the random forest was the best classifier. Why? Because random forest showed the highest accuracy and highest predictive accuracy. Okay, so this is a typical workflow of machine learning model. So what kind of software you can use for your machine learning problem algorithm? I recommend you can use the Python programming or R programming. So if you want to use the Python programming, you can use or you can download Anaconda 3 or any version of Anaconda, and Anaconda can be downloaded from this website, okay, www.anaconda.com, okay. And also you can use MySQL 5.7. That can be this is kind of difficult, but I recommend you to use the Python, okay. And of course the another software is R and Python is very popular if you want to solve the real life problems regarding the machine learning algorithms, okay. So this is the really the in fact the function of the Python programming is, I think you already know this one. Like you have to first load the necessary library, like the R programming. In R you have to load the library as well. What is the need of loading library? I think you already know that, and you have to load the data set as well, and the data set can be in different formats, either in CSV or from MySQL, like that directly from the database. And you can summarize your data to understand the pattern of your data, like the descriptive statistics. I also did the descriptive statistic analysis in my paper as well. You can also visualize your data to understand the data set, like you can do a lot of plots, a lot of graphs. I also did the same in my paper. And you can pre-process and data transform if you need. That means you have to split your data into train and test data set. Suppose you have 100 data, so you can split 70% as the training, 30% at the train data set. These are called the splitting of your data set. Why you have to split? You have to check the validity of the regression of the machine learning model. So what are the application of machine learning algorithm to training data set? To set up a machine learning algorithm and parameter settings, you can cross validation set up with training data set, training and fitting algorithm with training data set, evaluation of training algorithm or model and result, saving the trained model for future prediction, right? And finally, load the saved model and apply it to a new data set for prediction. All the criteria I try to use in my paper. So if you can take a look of my paper, you will have some basic idea how machine learning technique was used to accurately predict the mosquito abundance in northeastern Thailand. Okay, so before finish my class, I want to say, without data, you are just a person with an opinion, right? So Mr. Edward Deming told this quote, without data, you are just a person with an opinion. Okay, so try to deal with data, try to deal with machine learning algorithms, try to find the hidden pattern from your data, okay, whether this is leveled or unleveled. Okay, so stay tuned or try have fun with machine learning problems. So this is the end of today's lecture. So if you have any question, feel free to ask me.